after considering the lateral classification, we'll talk about the angular classifications. That the angular classification is classification of triangles based on the angle they possess. Based on the angle they possess. The angle they possess. Now, when you classify triangles based on the angle they possess, you'll be having what we call the acute triangle. These are typical examples of acute triangle when none of this angle is up to 90. This is not up to 90, this is not up to 90, this is not up to 90. That is an acute triangle. Triangle that has none of its side up to angle up to 90 degree. And then thereafter, we also talked about the obtuse triangle. When you have an obtuse triangle, one of its angle is greater than 180. Typical examples, greater than 90. As you can see this is greater than 90. This is greater than 90. If I draw straight, I'm going to be I got 90 from here to here. And when you cross over, means it's greater than 90. Talking about obtuse triangle. A triangle that has one of its side greater than 90 but less than 180. Then we'll also talk about the right angle triangle. The right angle triangle is simply a triangle that has its angle, one of its angle as 90. Right angle triangle, observe it. This is vertical and this is horizontal. The point they made here is 90. It implies that we also have the right angle triangle. Now, our major point of focus would be on the angular classification, focusing more on the acute triangle as well as the obtuse triangle. Previous classes we have considered and we have trashed and provided a solution to the right angle triangle. And now the right angle triangle can be resolved using Pythagoras theorem, which says that the longest side of a triangle being the hypotenuse, the square of the longest side of the triangle being the hypotenuse, is equal to the sum of the square of, if this is the opposite, square of the sum of the opposite and the adjacent. This is hypotenuse. All I have said is the fact that all right angle triangle can be resolved using Pythagoras theorem, which we have resolved in our previous classes when we started mathematics on this page. And therefore, that all right angle triangle can be resolved using Pythagoras theorem. What is Pythagoras theorem? It simply states that the square of the longest side of the triangle, which is hypotenuse represented with HYP, the square of the hypotenuse being the longest side of the triangle is equal to the sum of the square of the opposite and the square of the adjacent. This can be used to resolve all right angle triangle such that when you are given a triangle, the first thing that comes to your mind is to observe the triangle closely. Immediately you detect that it's a right angle triangle, straight away the solution to it is Pythagoras theorem. The square of hypotenuse is equal to the sum of the square of the opposite and the square of the adjacent. Now, what comes to mind? If we find out that the triangles we're dealing with is not a right angle triangle, that means this point is not 90. What comes to mind if the triangle you're dealing with is of this shape? Of course, none of this is up to 90. This can be regarded as an acute triangle. Or the triangle you came across was of this nature. Of course, okay, let me take it a little bit forward. Let me bend it like this. Of course, this is not 90. This is more than 90, as in the case of obtuse triangle. For a better understanding, when you are given a questions on triangles, and you find out that the triangles you're dealing with is right angle triangle, as in this case, whereby this is angle 90. I said the solution is Pythagoras theorem. The square of the hypotenuse is equal to the sum of the squares of the other two sides, and it can be resolved with that alone. But whereby it happens to be acute triangle, as in this case, or obtuse triangle, as in this case, you can never use Pythagoras theorem. What then comes to mind? What then comes to mind? The solution that will come to your mind is the sine rule and the cosine rule. The sine rule and the cosine rule. What is the formula for sine rule? Sine rule says that A is A all over sine A is equals to B all over sine B equal to C all over sine C. What I'm saying is this: if it happens to be an acute triangle you observed, or obtuse triangle, the formula that comes to mind is sine rule. This is a sine rule. Sine rule. This is a sine rule, saying that A all over sine A is equals to B all over sine B equal to C all over sine C. But not all the obtuse and the acute triangle that the sine rule can resolve. And when it cannot resolve it, what then do you use? You use what we call the cosine rule. And the cosine rule is simply saying there are three in numbers. Cosine rule are three in numbers. You have to learn them and store them in your brain. The cosine rule is saying that if A square is equals to B square plus C square minus 2BC cos A, capital letter A. Don't forget, this is the cosine rule. Cosine rule. The first formula or the first equation there is A square equals to B square plus C square minus 2BC cos A. Then the second formula that comes to mind is B square equals to, remaining two alphabet are A square plus C square minus this 2AC cos 2AC cos the B. The B you started with, observe it. Side B and angle B. Side A and angle A. So the last formula on cosine rule will be C square equals to B square plus A square minus 2AB cos C. You can as well bring A square first. Bring A square first before B. The formula is as simple as ABC. When sine rule cannot resolve acute and obtuse triangle. Another formula that comes to mind is the cosine rule. What is the cosine rule saying? Here is it. If you start with side A, it becomes a squared equals to the other two side, which is represented with either B or C or any alphabet. So if I'm starting with side A, then I'm going to say equal to B squared plus C squared minus these two sides twice of 2BC minus 2BC cos the angle of the side I'm dealing with. I'm dealing with side A here. It ends with angle A. Then another formula is B squared. If I start with side B, it's going to be B squared equals to the remaining two sides, which is represented with A squared plus C squared minus these two sides, twice of these two sides, which is minus 2AC minus 2AC cos the angle of the side I'm dealing with. Then also you have this, which is C squared equal to A squared plus B squared minus 2AB cos C. That is what we call the cosine rule. These two formula, the sine rule and the cosine rule, can be used to resolve acute and obtuse triangle and not right angle triangle. But reminder, all right angle or all challenges related to right angle triangle can be resolved using Pythagoras theorem. The square of the longest side equals to the square of the adjacent and the square of the opposite. And all acute and obtuse triangle can be resolved using either the sine rule, which is A all over sine A equal to B all over sine B equal to C all over sine C, or the cosine rule, talking about A squared equals to B squared plus C squared minus 2BC cos A. Or if I'm starting with B, becomes B squared equal to C squared plus A squared minus 2AC cos the B, the angle B I started with. Or it goes to C squared equal to A squared plus B squared minus 2AB cos C, being the angle of the side C. That is that for the solution or the way to resolve acute and obtuse triangle. See you in my next class as we continue with the concept of trigonometry. Thank you.